Stellar wind is a flow of neutral or charged gas ejected from the upper atmosphere of a star. Now, they really don't have an explanation for stellar wind. All they do is say, oh, it's radiation pressure. They say these winds are understood to be driven by radiation pressure on dust condensing in the upper atmosphere of the stars. Yeah, that's a very poor explanation because charged particles, guess what? They can be explained by something else entirely different. That process is called heterolysis. In chemistry, heterolysis or heterolytic fission involves cleavage of a chemical bond in a process where both of the electrons involved in the original bond remain with only one of the fragment pieces. During heterolytic bond cleavage in a neutral molecule, a cation and an anion will be generated. Typically, the more electronegative fragment will retain the pair of electrons. So you have the bond, when it's broken, releases a charged positive particle and a charged negative particle. And it can also go the other way, charged negative and charged positive. The energy involved in this process is called heterolytic bond dissociation energy. Bond cleavage is also possible by a process called homolysis. In a gas phase, heterolysis of a neutral molecule will require additional energy to separate the ion contact pair. This is very important because stellar wind is actually, because of heterolysis, it is direct evidence for chemical compounds, chemical reactions, both decomposition and synthesis reactions, and electrical current. Because as you will see, the neutral molecule will require additional energy to separate the ion contact pair, meaning that's electrical current. We all know what happens when a molecule is separated by electrical current. It's called electrolysis. In chemistry and manufacturing, electrolysis is a method of using a direct electric current to drive an otherwise non-spontaneous chemical reaction. In other words, this is not pseudoscience, people. This is basic chemistry, and they use it in manufacturing. So when people online want to tell you that you think the sun is electrochemical, not a fusion reactor, you can show them this. Electrolysis is commercially highly important as a stage in the separation of elements from naturally occurring sources such as ores using an electrolytic cell. The voltage that is needed for electrolysis to occur is called decomposition potential. Now this has enormous impact on our interpretations for solar behavior. Here I'm on the NASA website. You'll see the HMI colorized magnetogram picture. I'm going to go ahead and pull that up real quick for you. Alright, on this picture you will see electrolytic cells. There's positive, there's a negative, there's positive, there's a negative, there's a positive, there's a negative, positive, negative, positive, negative. The energy of these cells is released as solar flares or coronal mass ejections if these are to short circuit. Basically, what you're looking at here are battery cells. Now, the important part is, what is the reduction potential of this versus this? Which one is the actual anode? Which one's the cathode? I'm sure somebody probably already knows that. And what exactly is this material comprised of, really? Is it just hydrogen and helium, as the experts tell us it is? Or can we actually determine what this material is by the composition of the solar wind? Now, I remember looking into solar wind and looking up some things about it, and apparently all types of elements that are charged come out of the sun. So it's not just helium and hydrogen. So that begs the question, what do these materials mainly comprise of? And how do they evolve? These large battery cells apparently get closer and closer, as you'll see here, and eventually they start neutralizing each other. Check it out. And the solar wind increases because large-scale heterolysis or electrolysis is occurring in these areas. Now, what happens over time is these little processes, these energy storage mechanisms, they do neutralize over time, and the sun will die, meaning the solar wind will die. The sun won't emit solar wind forever. This poses a huge challenge to solar physicists, because it means their explanations for solar wind production need to be replaced, because radiation pressure is very, very poor, especially when you ignore chemistry and things like electrolysis. Now, it is important to study these objects because it means electric current is involved with solar activity. It's massively involved. You have electrolytes in there, you have ions, you have electrical current, you have direct current, you have electrical conducting material, that's the plasma. You have electrodes, and you have a whole bunch of different kinds of material inside of the sun. You have potassium, sodium, barium, calcium, magnesium, gallium, aluminum, sodium hydroxide, and these are chemical experiments that have been done. Noted, why don't we apply these kinds of experiments to the sun? Basically, the reason why they don't is because the sun is a fusion reactor. It's too hot to form chemicals. Yet, as I've overviewed earlier, the fact that it has solar wind basically refutes the claim that the sun cannot have chemicals. If the sun didn't have chemicals, there would be no solar wind. As well, if there weren't any electrical current, there also wouldn't be any separation of the chemicals into what we call solar wind.